So, in a normal organism, proliferation isn't something that happens often. Proliferation is just how cells divide and replicate. So, continually divided from 1 into 2 into 4 and continuing that. Normally they don't proliferate. So what happens is we have these specialized cells inside our bodies called stem cells. Stem cells, their main job is to proliferate and eventually differentiate. So what happens is these stem cells stay inside of what we call a niche, which is just a specialized area. So we have stem cells that will essentially keep on dividing inside the specialized area called a niche and differentiate into specific cells that our body needs. So say you want to create bone, you would have osteoblasts. So you'll have proliferation, constant proliferation of stem cells to create osteoblast. And what happens is, as they proliferate, they'll create one osteoblast and one stem cell, so that the stem cells can essentially keep regenerating and keep proliferating to keep creating these specialized kind of cells. Outside of these stem cell niches, we have controls for proliferation. So one of the controls is the telomerase, which is the very end of DNA. So we have telomeres at the end of DNA that essentially keep shortening as they proliferate. Shut up, Rich. And as they proliferate and as this gets longer, it tells the cell it's coming to the end of its generation. And after a while, once it becomes so short, it can no longer proliferate and then no longer divide. Another way that we control proliferation outside of these stem cell niches is by contact inhibition. So a cell actually telling another cell that's close by to stop. And that goes into kind of what Delta and Notch do by inhibiting it from becoming into one of these niche-type cells. So cancers are specialized mutations or issues within a cell that cause overgrowth or lack of control of that growth. So the cell will grow out of control and keep growing and differentiate. And there are different ways that they can have cancer, essentially, or cause this outgrowth. You can have mutations inside, which are either gain of function or loss of function of these genes that regulate the cell growth and proliferation. Or you can have non-mutagenic, which could be loss of memory cells, such as the histone modifications and DNA modifications that we talked about, that allow the cell to remember only to grow to a point. The other thing that happens is change in cell metabolism, which is the Warburg effect, which we'll talk about a little bit later. Cancer itself is not inheritable. You can't inherit cancer. So things like breast cancer, you don't inherit. But there's this theory called the multi-hit hypothesis that essentially, instead of inheriting cancer, you inherit mutations within the genome. And to have something like an overgrowth of cells and constant proliferation, you're going to have 2 mutations. So if you inherit one mutation, say from your mother who had breast cancer, and one non-mutation from your father, you're going to have a one hit. So one of the genes is going to be knocked out. And the likelihood that we're going to have mutations in our body through radiation or other systems is going to be much higher if you already have one hit. So,
okay, I agree.
Did you already stop it?
No.
Oh, okay. So, the multi-hit hypothesis is if you inherit one of these mutations that already occurs in the cells, all you need is one mutation to have this outgrowth of cells. And that's called the multi-hit hypothesis.
Okay.
You can stop.